Hello and welcome to the AI Digest. My name is Joaquin Melara and I'm your host. With me today is Dave Duggal, and he is the founder and CEO of EnterpriseWeb. It's a pleasure to have you, Dave, and it was nice to meet you in person prior to this interview. Uh, you are you're I think you're the kind of person that I expected. You're really tall. I don't know. Sometimes you can look at a person's face or makeup, and you can make some assumption of their height, but you're tall, man.
That's,
Uh,
that's yeah, it does mean that my feet hang off the bed and I hit my head when I go into my closet on the transom. But so it's not a little bed of roses being tall. But Joaquin, great to be back with you, and it was nice and serendipitous to sort of run into you. Um, we had spoken a couple of times, right? And it was nice to run into you in New York City at that Amazon event there on Graph.
so that's a perfect segue into Happy New Year.
Oh,
Uh,
good to meet you.
this is we're recording this on January 4th, so relatively brand new year, and you had something to say about the new year and
Well,
a prediction.
I have an optimistic prediction. I've been in the trenches for a long time, but my optimistic prediction is, and mark you can mark this day, is that 2024 will be the year of the graph, right? I mean, clearly 2023 was the year of generative AI, right? It fascinated the entire world, really. But I think as the year went on, and I think it's fair to say, actually, the limitations or the inaccuracies and the inconsistencies of LLMs sort of generated an interest in knowledge graphs, because people understood that these LMs needed to be compensated, right? There's an understanding that despite these great strides in deep learning, that domain knowledge provides context for all forms of AI, right? It's actually one of the reasons why so many AI initiatives have failed in the past as well, because people come in and say, "I need AI," and they try to make AI like it's a tool and just throw it at a problem. But AI is also better served by having context. And I think there's sort of a simple explanation for that is that as the numbers and types of LLMs explode, and different approaches are going to emerge, which is clear, right? We're going to have more than one LLM. So 2023 started off with the notion of OpenAI and the large language model, and now we're
Right.
already talking about small language models. But no matter where that goes, right? Because and transformers, that kind of transformer technology is not the end all, right? We're not even at the end state, right? But the one thing that is true, and the reason I call it the year of the graph in 2024 is because there is a growing awareness is that the domain is the key asset of the enterprise, right? It's domain knowledge. The domain graph is the asset. The LLM is not the key asset. It's in
Right.
fact, it's sort of
It's an
algorithms.
interface. It's an
You might have right? We have many algorithms, right? Time series, cost, location based, right? Temporal analytics, all these different things, right? And we'll have different kinds of LLMs and different kinds of AI. That's all great, but they'll be like almost like artifacts, right? Tools we use against our domain to interpret the domain, right? And to actually even, of course, help create and extend the domain as well. So they'll fold into each other. But I really think that the central asset is the domain, right? It's that single source of truth that grounds everything across the enterprise, even just regular intelligent automation, even without AI, right?
I
Because I
think
think, go ahead.
I think this is an excellent segue to talk about where you come from because you were originally a business person who
Yep.
was making decisions that directed an organization, the use and budgeting of its resources, managing staff. So you come very squarely from the school of thought of like what works, how do we employ uh, resources, people, information in a way that we make this organization a productive entity. Can you share with us a little bit about your background story, your origin story, 14 years ago?
Yeah, sure. So my I'm a little bit I go back a little bit further than that. So my origin story is essentially I my entire career I've built, turned around, grown companies, right? My own and others, right? That's what I've done. I am business guy. I come from a family of entrepreneurs, and I'm carrying it on. And I've always felt, even as a business executive, I've always felt this need to own operations all the way down. In other words, I felt like I couldn't manage something I couldn't understand. I couldn't manage something I couldn't see, right? So as my career advanced through several companies and experiences of my own, I saw this recurring pattern that the automation technologies that we built in the 20th century, really all into, up to, let's say, SOA, service orchestration, and essentially service-based architectures, which are essentially still what we use today, right? Is the 20th century form of automation that we did was based on technology stacks, right? Creates these technology silos, and that these technology silos essentially were the enemy of business agility, right? If I'm a business guy, I want to look down on my business. I want to see the people, the information, the capabilities which are the core assets of my business, and I want to flexibly connect them for purpose, right? Based on events and policies, whatever. I want to be able to control, understand, manage, audit, all those kind of things. And that's sort of where the name Enterprise Web came from, right? Is I want an enterprise web, right? I want everything to be an object in my system, an object under lifecycle management, an object under governance that I can control and flexibly manage. I was getting tired of development teams telling me what I couldn't get done, right? I was getting tired of every time I had a business requirement, which was, remember, the business is run based on behavior, not just data. Like, data by itself is great, but just like in education, if you don't use it, if you don't apply the education, then you haven't really achieved much, right? So data in a business is great. It's, maybe you could call it the lifeblood, all those, cliches. But actually, the purpose of business is action. And what is the action? It's delivering meaningful experiences. It's about delivering value. It's about delivering behavior, right, to customers, right? Whether that's products, experiences, whatever it is, it's about. And if you then just follow that thread, well, what's the best behavior? The best behavior is contextual behavior. The best behavior is real-time behavior, right? Just like this conversation, right? You've got me on the hook for an hour or so now, and I'm sure, go into a lot of different corners, and we're both going to respond in real time to each other, right? We have active
instant feedback loop, stimuli, reaction. Yeah.
But it's more than just feedback. It's more than just beck and call. You have sort of a model of the universe that you've evolved over years based on your experiences, and so do I. And when we talk, we're achieving some form of interoperability based on being able to contextualize and ground our exchanges between each other. And your model of the universe can change based on my inputs, and so can mine, right? Your inputs can change my model of the input. So we're talking about a very dynamical system too, right? So it's dynamical, model-based system that's highly contextual. And so that's what I was looking for. I wanted to essentially do, you think of in a factory setting, in the last couple of decades, this concept of mass customization came out, right? Like, where every single person could get something made that was custom to them, right? And in a mass scale, right? So you get the kind of efficiency. And what I wanted to create was sort of mass customization of experiences, right? Where everybody's experiences, where I could create models, and the models would be generic. They would reflect what the kind of things I wanted customers to do, or be able to do, or be able to experience. But then within that model, it would allow for the personalization and optimization for that individual or for that event, if that makes sense.
No, it's smart. You create a model that fits many different potential scenarios, and you fit that model across unique experiences that you want individuals to have. And you tune it, and you get the data, and you reinforce what works, and you fix what doesn't work. You alter and modify as needed, and it's an evolving journey, right?
And an evolving architecture, right? You're building something that's built for change, right? You're building something that's designed to personalize interactions, grow with the feedback of those reactions, whether they're positive or negative, take those inputs back in, right? And the system itself needs to evolve as well. So there's a temporal aspect there as well. And those are the hardest things in computer science to design for. The hardest things to design for in computer science are distributed systems, variety, in other words, that you have lots of different things to connect that they're all that might not be standard, right? So you have to deal with heterogeneous elements, and then you have to deal with change, right? So you have to build systems that can respond dynamically for a context, accommodate change, support history, and that's a big ask, right? And that's why probably my IT teams weren't initially giving it to me, and why I set out to build enterprise web is because it's a big ask, right? It's like we've have had let's see, it's 2024, so we've had essentially since the 40s about 75 years of real computing, going back to Turing. And we really still don't, if you really think about it, the modern enterprise is still siloed, generally imperative code, static, right? Very few business leaders would say they have the business agility they want in their systems. They would all agree that they want to be more contextual in their experiences. Why is that? Why hasn't technology delivered that? And that's when I set out to go back to your question. When I set out to build enterprise web, that was my thesis. The thesis was, yeah, okay, we keep on getting new toys and technologies here and there, but effectively we're still following an old paradigm of siloed technology and sort of now increasingly unwieldy cloud native tool chains. And these tool chains and stacks were creating the next level of problem for interoperability across them, right? The biggest problem in 2024, which formerly in 2023, is that how do I have global visibility? How do I have global transparency? How do I do end-to-end automation? Not within a silo, not within an office. How do I do it end-to-end across my organization? How do I do consistent policy management across all my different teams? If I'm the business guy, again, if that's my perspective, I'm the business guy. Well, I want to be able to apply policies and governance across my entire organization. I don't want that to cost me $50 million over 5 years. I want to be able to, on the top, at some level on the top of an ontology, on top of a graph, I want to be able to say these policies apply everywhere and they're effective immediately. That's agility, right? That's business compliance. That's IT governance, right? So I wanted to get above the silos, right? I wanted to think much more broadly in domains. And graph is part of that story, but it's not the whole story. And in one thing, if you might, I think you already know, but for the audience, it's not just I'm not just talking about a graph of data, right? I'm talking about a graph of behavior, right? I'm really talking about ontologies, right? Concepts, types, and policies, right? I want graphs that connect functions and systems and databases and services to business concepts and people and under policies, right? So it's a much bigger notion of a graph than is commonly practiced in the sort of off-the-shelf products you get.
Okay, so this is what led to enterprise web. Your frustration with what was available on the shelves, what engineers thought was possible. People hadn't bothered to view it from the perspective of a business. I want all these capabilities to be true, and I don't want to compromise for what's available today. So you went out and as you stated in the time that we met each other in person, just consumed a variety of PhD theses to get a better understanding of different perspectives of how to mathematically outline the function of an organization, because an organization serves to receive an input, transform that input some way, somehow, with information, resources, people, and produce a tangible output that leads to more resources, right? That's the idea of a business. You're there to make money. You're there to produce something of value, and people are going to pay for it.
Yeah.
Um, so, can you tell us a little bit more about what were some of the influences that led to your way of thinking as to why graph is the way, and not just a particular flavor, a particular implementation of graph, but the conceptual understanding that everything around us is a soup of graph: verbal, cognitive, behavioral, information, resources, everything's transactions, everything's a graph.
Yeah.
Um, Can you tell us a little bit more about that?
Yeah, so that's a big remit you just gave me. So you're gonna have to allow me to expound for a little bit. So so first going back to your first thing. So I think that's pretty common that innovation comes from frustration, right? I believe, and you can maybe you or your attendees can fact check me, but I believe it's Benjamin Franklin who said, "Necessity is the mother of invention." Right? You run into it, you solve, you don't solve things that you don't know are problems, right? So it's only when you run into a problem and and you revealed that you know me in the sense that you know that I'm not going to compromise. So I was like, okay, well, I see this problem. So before I set out on a solution, I was like, okay, first of all, I really need to understand the problem space, and I think that's just reasonable, right? Like, why isn't this problem solved? Right. And the reality is, I'm not the first person to see or identify this problem. There's a very famous computer scientist, Backus, who I think it's Backus, that gave a Turing Award speech in this, I think, well, I want to say 71. Excuse me again for you though at home if I make any slight incorrections or misrepresentations, but it's Backus, I think around early 1970s, who gave a whole speech and saying it's like, why are we building software based on the constraints of our hardware today when we know that Moore's law is increasing compounding computing capability year on year?
Right.
So why would we ever build our software for a current constraint when that current constraint won't be in a year or two or three? And just look in our recent lifespan, look how much that is true, right? Go back in the 90s, compute, storage, and network were constrained, right? I mean, I remember when I was living in New York City, my dial-up internet and all that, right? Like waiting for everything. I remember working on computers in the 90s in New York City and doing high-end graphics where I had to have 3 or 4 Macs running at the same time because a single filter took 30 to 60 minutes, right? Compute, storage, and network were constrained, right? But now you think of it as compute, storage, and network commodities. The only thing we expect now is the price of that stuff to go down every year, right? That's what we expect. We want more. I want more on my phone. I want more video. I want more, right? But still, software is built the same way, right? We generally build our software called in an imperative manner. Imperative just means it's coded, right? So even code has a model, but the problem with when you do code, the model is implicit by whatever the developer wrote, right? It's not transparent. As opposed to graphs or modeling, you're actually making models explicit. That's a more declarative form of development or design, right? Where imperative is like you encode things, and as you encode more encoded, when you take a set of encoded things together, you create these really brittle structures, right? Where everything's manually integrated, everything's opaque, everything's a black box connecting to another black box. And the problem is, right, this is the universal canonical problem is, well, when something breaks, everybody goes like, oh, what broke? I don't know. There's no model. There's no transparency. I can't see what broke. How do I find out what broke? I go into the code. So what's your mean time to resolution on that, right? So what you were talking about when you were summarizing what I had described about everything being graph and everything being models and sort of contextualizing things, what you really were describing was declarative programming, right? Declarative programming is the separation of models from implementations. I can have a model of something, but the model is you expressing at a high level what you want to achieve, goals and intents. And then if I do something declaratively and I do that in a model, it allows me to late bind the context, right? So that the implementation is independent, right? So I can actually, the computer can say, okay, I got your model, and I'm going to inform my processing with some real-time data to actually respond to you with a contextualized response, not just a response. Because if I design something imperatively in code, what you're essentially getting is it's the context of the developer at design time, and it's not changeable, right? For everybody's going to get the whatever that designer did, whatever parameters he put in, you ain't getting nothing different, right? And that's why imperative code is static and rigid and brittle, right? And then when you build systems out of a lot of connected imperatively coded, static and brittle pieces. The whole system, you're building up a system that is inherently brittle. But if you build it out of models, you're putting transparency first. You're going to say, I'm going to explain myself first. I'm going to explain my entities and my relationships. And let's make this a little bit more accessible for people. I mean, what is an organization? Well, an organization is a graph of people, information, and capabilities that come together on events and policies. What is a process? A process is a graph of tasks, right, that have relationships that come together based on events and policies.
Hmm.
What's a service? A service is a set of elements, functions, and data sources that come together with relationships that come together on events and policies. Right? Everything can be described as a graph. And why do it as a graph? Well, because graphs are fundamentally more, and I'm now speaking generically about graphs as a computer science. I'm not speaking about certain graph technologies, which like
Right.
RDF, certain technologies like RDF and LPG are more constrained. But graphs fundamentally are math, right? So graphs are inherently flexible and extensible and adaptable. Graphs have tremendous properties of associativity and adjacency, and commutivity that sort of the old structured hierarchical relational databases don't have. Here's a great example of that. Every organization has an organizational chart. If you get to a big organization, that organizational chart is a big mess, right? Because you're trying to force something into a hierarchy that doesn't really want to believe, it wants to really live as a graph. But why? Well, because an organization is a set of units, but those units do have parents and children. That's true. That can be represented in a graph. But you also have, like, I don't know, maybe you have a research institute, and you have sort of a extra hierarchical nodes that sort of maybe live outside the hierarchy. Maybe you have one-to-many relationships where, well, this unit doesn't actually belong trapped only specifically under this tree of parents and children. It actually belongs sort of awkwardly between a couple of different things at different layers. Well, now you're fundamentally not in a hierarchy anymore. You're in a graph. So a graph is a better way to represent an organization. Graph, hierarchies are a constrained form of graph, right?
Hmm.
That's what they are. A graph is open, right? You can have a
Expressive.
undirected, right?
Yeah.
So I mean, I could go deeper into sort of some of the foundational computer science, the thinking that I saw, like where I went to sort of pull out some of these ideas. Of course, that could be its own discussion. Um,
I think you
you,
outlined some pretty core elements of your theory and and the discussion points here. There are entities, there is information, there are capabilities, and there are events and policies that pretty much boils down the atomic parts of an organization and how you can construct them into molecules and units and build a hierarchy. There are limitations with the way that conventional business people or business practices view organizations, but it doesn't really express or bake in the context and knowledge of how individual actors in a organization act within each other in that organizational space. You could have a hierarchy map stating this is the boss, this is the manager, and here are the employees at an entry level, but that does not exemplify who each actor is talking with, how information is flowing throughout the organization, where are the constraints in information flow, or who needs to report to whom, how are decisions being made. There's a lot of detail that the richness of the real world that is missed with these static two-dimensional representations of what the real world is.
yeah, it's a easy way to say that is hierarchies force conformance, right? It's square pegs into round holes. Um, you're taking a structure and saying conform to my structure, as opposed to let me model what really is going on.
Mm.
And that's one of the reasons why AI, at all forms of AI, including generative AI and analytics, all do better with graphs than they do with hierarchies. Because if you think of it, all forms of analytics and AI are based about identifying patterns. whether it's it's the next, or like an LLM thinking about the guessing at the order of words, or whether it's making doing observability and looking down on a running service, and you want to observe the service and its performance, and you want to do some algorithms over the top. AI works better over graphs because graphs give them patterns. Graphs give them structures that they can recognize. It gives them that domain knowledge in a way that AI can readily consume. Where hierarchies trap data, and obscure real world activity, and make it harder. And again, that goes to why a lot of enterprise AI initiatives fail, is because they apply the wrong technologies to they're not matching technology to requirements. So they've got an alignment gap, and that's going to, whether they see it immediately or not, it's going to fail. And you could predict that up front because, as you and I were discussed previously, architecture is prelude. Architecture is destiny. You don't have to wait 3 years for the implementation and spend $20 million or $50 million. You can know up front. If you look at the architecture and study it, you could say, oh, these will be the affordances. These will be the natural capabilities. This is the way it will extend itself over my operations. This is what I can predictably get from it and how it will scale and evolve. You could do that from you can do that from just studying the architecture. You don't have to implement it first and learn the hard way.
I think you can even extend that to the physical world. If you read the architectural blueprints of a house, you know how many people you can fit in there. You know how many people can fit in the dining room, or how many bathrooms you're gonna have. You're not gonna build a house and expect there to be a pool if it wasn't on the architectural blueprint. You're not gonna expect to be able to fit 5 cars if you only have one driveway. So I think that that is a pretty nice way of representing
Sure.
graphs.
If you're going to put a helipad on your roof of your house, then you better have built the structure to support that helicopter. If the foundation doesn't support what the intended use is, you're going to run into a problem. And this goes to another problem. People tend to blur the graph as well, right? They think of graph as a singular thing, right? Generally, it's semantic web or labeled property graph, or LPG. But graph is, again, a domain. It's a domain of mathematics that goes back hundreds of years, and the notion of objects goes back to thousands of years to Aristotle. So, so it's important to look at the technologies you're looking at. And when I was doing my research, one of the things went to a lot of graph conferences. I know a lot of people in graph. I read a lot of not just academic papers generally. I read a lot of graph-related academic papers. And there's serious constraints of RDF and LPG that really aren't discussed publicly. I don't even think they're really widely understood. Yet I can tell you from enterprise experiences, from customers I talk to, and prospects and partners, there's a growing awareness when they implement some of these technologies that they're not supporting what you and I have been discussing, was this real-time distributed systems and operational behavior, right? They're not giving them that business agility. They might be doing great on analytics. They might do great on recommendations. They might be doing great for sort of understanding relationships from a data science perspective. Those are valid use cases. But you can't just assume that you can then build your house on top of those technologies, because those technologies fundamentally were not designed to support business behavior, real-time, ad hoc, complex queries. They don't scale the right way. They don't update the right way. They don't support temporal, time series analytics. So
This is a commonly well-known problem that companies tend to hype and drive a narrative that their solution solves all problems, because that's what leads to dollars in their pockets, right? I mean, you can't expect someone selling you something to not further agitate the problem you're having and paint the picture that their solution is going to solve that problem. Um,
if you have a hammer, everything's a nail, right?
I really enjoyed this allegory from the book Code Complete, that says if you're a computer scientist, You need to treat it as an engineer treats the real world, and you need to understand the materials and the problem spaces and the physics of what it is that you're trying to solve. Because wood does not behave like aluminum or steel or any other kind of material, plastic. They all have their own different properties, malleability, all these different electro or heating conductivity. You need to think about the problem that you're trying to solve, and then you go seek the materials. You don't just pick the materials and then try to solve the problem with what you have on hand. It leads to a suboptimal solution with constraints baked into it. So what
You're building in failure modes that you don't even know, right? That's the problem. I think there's a bigger problem there too. And so actually, I need to get that reference after our interview here, because I hadn't read that. But it's something I say something similar to a lot of people in standards bodies, right? Like if I work in a lot of big spaces, life sciences, telecom, IoT. We go to a lot of conferences, and there's lots of people generating standards. And a lot of times, the standards architects almost pride themselves of being independent of implementations. And in a way, of course, that makes sense. They want the idea and the requirements and the objectives to be independent of the
flexible?
technology, to
Yeah.
be independent of the technology that's going to implement them. But the problem is, if you just design something willy-nilly, I mean, anybody could draw a lot of pretty boxes on a PowerPoint, right, or on a whiteboard, and connect things and saying, and this will magically result in da da da. If you don't understand the affordances of the presumed participating technologies, and you just throw that over a wall to IT and say, just build that, right?
How?
Yeah, now you have this implementation problem, right? Like, how are they going to do that? And then, yeah, at some level, it's going to satisfy some of the requirements superficially, but what it won't do, almost inevitably, it's not going to solve the sort of hard architectural problems of, okay, you built this, but it's not agile. Okay, you built this, it doesn't evolve with change. Okay, you built this, but it's not highly interoperable. Hey, you built this, but it doesn't scale. Hey, you built this, it's not performant. So the thing is, I'm like, okay, yeah, when you do architecture, you want to somewhat keep it pure, but just as you were describing for computer scientists, is you want to think holistically, right, across a problem space, right? Think of it this way: lots of people will talk about their IT initiatives as moonshots, and okay, well, when they went to the moon in the 60s, in 9 years, and we put a man on the moon, built the rockets, everything like that, they didn't start with the easiest problems first, right? And just presume it would work out. They started with the hardest problems first, right? It's a moonshot, right? They had to think, it was like, how do we get something off the launching pad? How do we create a trajectory that's going to put them into orbit? How do we safely land them on the moon and then get them back off the moon? How do we take that return craft and bring it back to the moon, Earth, without burning, without skipping off our outer atmosphere, and going into outer space, or burning them up in our atmosphere, right? Well, you can't just solve one of those problems, or two or three of those problems, and say, call it a day, and say good enough, right? You have to solve those problems collectively, right? Because in solving one problem, you might undermine another one. So you have to actually reason them together, right? You have to evolve that thinking together. So that was very much the journey of enterprise web. So I think conceptually, we've had this discussion, and everything resolves to a graph. How we actually ultimately implemented that, this is real innovation, right? We have 20 awarded U.S. patents on how graphs support complex distributed systems for context-aware services, right? That how you could do that at scale over time, right? So how you can build integrated systems that evolve in time and space. That's a big computer science problem, and that I didn't realize it when I started the company. That was a problem ultimately I was going to have to solve. But to give ultimately the business something practical and easy and declarative, hey, just express to me what you want and declare your intent to me, and the runtime is going to make that possible. And don't worry about reliable messaging. Don't worry about transaction controls. Don't worry about state management. The runtime is going to take care of all that for you. It's going to all be abstracted away from the user, because we want a much more no-code like NLP type human-like experience. Well, of course, making things easy is fundamentally hard. So I think I undid myself at some level. Is I picked a hard target, and we spent years before we ever talked to a customer. I literally found my chief system architect, Bill. I stumbled on his work in an academic paper, actually, when I was reading them in Mass. And I reached out to him. I literally flew him down to New York City. I told him my vision of what I wanted to achieve. He was working on dynamic interoperability in healthcare settings. And I said, I want to build a fully agile enterprise system that's all contextual. And I want everything to be modeled in the graph. I don't want anything outside the graph. I don't want any hard code anywhere. I want the graph to represent everything. I want the graph to even represent the platform technology itself. In other words, the enterprise web, our technology is implemented in our own graph, right? The experience you get of enterprise web and the things that you can build on enterprise web are built out of the same graph, right? It's just another layer down. We hide that complexity because, let's face it, most people don't even really understand what a graph is or how they don't really care. Why should they, right? Once again, if you're a business person or if you're an engineer, what you really want is you want to speed and ease your work, right? You want to um, make things easier for yourself. You want to automate your tasks. You want to be more powerful. You want to work on top of a higher level of abstraction that enables you to be more productive. And you want your customers to have better, you want your product that you put out there to give more contextual experiences. To give you an example, one of the things that we targeted immediately as from a domain perspective was telecom, because telecom is almost like the apex of system complexity. I mean, except when you talk about the militaries or something like outside of militaries and things like that, really the telecoms are some of the most complex organizations in the world. Not only do they have all the distributed systems complexity that a normal enterprise might have to encounter, they also give you the network. And that, guess what? That network is also built out of it is a distributed system. And it has to be reliable to 5 nines, right? 99.99999%, reliable and available. So that's a high, threshold to make a system like that. That's also they also want to be more dynamic and agile too. There's a whole telecom initiative to make digital service providers to move away from being infrastructure bound to be much more software centric. So telecoms could be more cloud like. They want to do that too. They want to do that with the network. They want to be more responsive to their customers. They don't want to lose everything to other software companies. They want to be able to act more like a software company themselves. And enterprise web has sort of been a pioneer in that domain, sort of making that possible. So building graphs that can support those kind of complex real-world operations was a very high threshold that we had to meet for reliability, availability, scalability, performance, security, governance, all those things.
I'd like to take a step back just for a second. So there's the World Wide Web, the internet, which is supposed to be this interconnected mesh of devices across all these continents, all this infrastructure, making sure the computers are able to communicate, share information and bits of data through Ethernet, satellite systems, etc. Your company, EnterpriseWeb, is a localized soup of information within an organization, modeling it, architecting how events and policies shape the behavior of the actors inside. Is that the way that is that the idea behind it?
Yeah. So the notion of enterprise web, again, was sort of that notion of this umbrella abstraction, right? I want to be able to look down on my organization. That was sort of the motivation, right? I want to look down how things are. I want to then be able to compose. So declaratively compose. In other words, I want to be able to take those, what you described as sort of heterogeneous and distributed, elements that might be residing anywhere, right? In the hybrid multi-cloud, they might be partner services that you're calling on. All these different aspects that come into it. I want to be able to say, hey, in enterprise web, all this complexity of being distributed, dynamic, and diverse, I really just I want to look at the world a little bit differently. I want to look at it a little bit more flat for convenience. That's what an abstraction does. I want to be able to say is like, really everything can be looked at as, I realize that the world is really complex and heterogeneous and all those different things. But if I look at everything as a snowflake, all I'll do is I'll break down and cry. It's just too hard, right?
Yeah,
I want to be, for my convenience as a business person, I just want to have a catalog of objects, a catalog of typed objects, a catalog of typed objects where everything just lives in there, and like literally, people are represented as objects or digital twins. Things and systems and databases are represented as objects or digital twins. Services, functions, processes, all just get represented. And in this catalog, I have one common, uniform, harmonized representation of everything. Now that catalog is hiding the fact that they're not all necessarily the same. It's presenting them to you so that you could look at them as if they were the same, so that you could look at them all in one place as if they were all local, even if they're not all local. But that's an abstraction that gives me power, because now I could, instead of me like thinking of the world as for what it is, it's, oh my God, it's this mess of stuff. And I can only just hard code that all together. And then it's static and it's brittle and breaks. I don't have visibility. I don't have the controls I want. Instead, I go to this catalog. I model everything in a catalog. I model everything as graph objects of a domain, of a graph domain. A graph domain that's connected to a upper ontology of, so I have this just really interesting graph that connects the entire enterprise. And through that, I get shared metadata, shared relationships, shared state that can be leveraged across my different teams. So now that graph is helping me connect teams. It's helping me connect technologies. It's helping me connect my operations, because I have this single source of truth that's providing a useful abstraction that everything could be described as a typed object in a catalog. And when I deploy things, they go into an inventory, so I can see everything that's deployed and running. I can understand its health. And this graph is, call it a facade if you want, right? It's a window into that universe. And from the graph at one level, if I don't want to see the ugly, nasty reality of what all that is, I could stay at this high level. I could just look at my control panels. I can look at my UI or my API in Enterprise Web, and I could just look at the sort of harmonized universe. And guess what? If I'm a business guy, believe me, that's what I want to do. Mm-hmm. If I'm an engineer or an architect, sure. If I'm an architect, I might want to look at the graph itself. I might be responsible for the extension of that domain and the type system and all that stuff. If I'm an engineer, I might like the fact that the graph makes me more powerful and more productive. But I might actually want to be able to drill down. And since it's a graph, I can drill down from the abstraction that Enterprise Web creates. So in Enterprise Web, I could literally say, I want to take this element, these three functions together, and connect them with these policies and connect them with these systems and databases. And I want to deploy it here. And another aspect of it's going to be run here. They're going to be connected by this network in this fashion. And it's literally about as easy to do that in Enterprise Web as I just described. I mean, we have demos online where we build on the fly, we build a 5G edge network in using generative AI. So you literally speak to Enterprise Web through natural language programming, and you can build out a 5G, edge network in 5 minutes, and we spin up the entire network. like that's something that would take teams of engineers weeks or months to do. We can literally do in minutes. Now, if I'm the engineer, though, if I want to drill in, because it's a graph and everything's connected, I can actually follow those objects and I can walk the graph down to the actually underlying things themselves, right? I can find the image of, or the artifacts or the files. I can walk all the way down to the service endpoints. I can actually see what's actually being modeled. Some people will need to and want to be able to see that from an audit perspective, from a troubleshooting perspective. So Enterprise Web is giving you that graph. We're also giving you the history. So we see the history of every transaction through the graph. So I can, so if you want to go back and say, hey, why did this fail? I can present you that interaction at a moment in time, show you a full trace of everything the system connected. And I can show you even where the system failed. Hey, I tried to call this service 5 times. That's what the policy told me to do. But after the 5th time, I gave up trying because that's what the policy told me to do, and I failed the entire service because it's a transaction, and I can't have a partially deployed service. And since that element wasn't reachable, I shut down the whole service and I reported it back to the person who requested it that the attempt failed, or maybe I retry it somewhere else. But having that kind of transparency all the way down, so that's kind of the breadth and depth of graph we're talking about, right? I want at some level, a level of convenience. I just want an abstraction that hides complexity. But think of it this way. Actually, in generative AI, one of the things that people have really come to know is, well, generative AI is a stochastic parrot. It doesn't have any explainability. It's one of the biggest problems why it's slowing down adoption in the enterprise, right? Is that you earlier on in this conversation, you said, well, pretty much all behavior, pretty much all enterprise activity is about inputs, transformations, and outputs. You're absolutely right. And in a declarative system, those inputs, transformations, and outputs are all transparent. In
Right.
generative AI, you have
You
no
can't.
idea that.
Yeah.
How it came to its conclusion, whether it's right or wrong, you don't know. When we work, so we collaborated with Microsoft on an award-winning uh, enterprise-grade generative AI for service orchestration. We're already able to demonstrate, working with generative AI, how I can speak to enterprise web, and generative enterprise web's graph, our concepts, types, and policies ground the textual or voice-based prompt to the LLM. They ground that and they transform it into enterprise web. And it's actually enterprise web that's actually taking the action, and then verbally communicate. And then when we take the action, we report that back to the LLM, back through natural language, to say, okay, you requested I deploy that service. Did you mean this kind of service? Please confirm. Yes, I meant that kind of service. Okay. 30 seconds later, your service is now deployed and running per specifications, right? We were able to deploy, we did that last May at a major telecom conference. We unveiled it and honestly just blew the room away, right? It was actually, we were demonstrating it live. Nobody'd ever seen that before. LLMs are pretty new to most people in May of 2023. And people were all holding their phones up, videoing our demo like it was, a Tyler Swift concert or something. And I'm sorry, Taylor Swift. It shows you how out of pop culture I am. Uh, so one of the great things about graphs in this kind of context is explainability. I do. It also is when we describe all the things, and it's sort of interesting. Joaquin, you're actually you're grokking all this stuff intuitively, right?
Well, I was the support engineer managing distributed enterprise systems for an educational technology company.
Oh, okay.
I was a technical project manager for a small family-owned software architecture firm, and they sort of threw me at multiple projects. So I'm used to going into the roots of the database, architecting the schema, conducting subject matter expert interviews, and then analyzing, synthesizing how everything functions in the organization before opening my mouth to say, "Hey, I think we should do it this way," because I don't want to run any fool's errands or misspend my resources or misspend the valuable time and energy of expensive engineers. Um, but I'm all for how do we deliver value for the business without building things that aren't useless or that aren't bloating or unnecessarily introducing layers of complexity that are just going to make it more brittle.
Yeah.
Um,
And you used it. So first of all, that is interesting, and again, so sort of hands-on operational, right? You took it all the way down. You
I
trained
needed
your
to touch. I can't trust anything that I don't see. I can't trust anything that I can't touch. If I can't see, smell, hear, or interact with any component of the system, I had to protest, yo, I need access to the database.
yeah,
Yo, I gotta see what the schema looks like because if I don't, I don't know what I don't know. And this is the artifact that shows the outline of the organization's data systems and
yeah,
processes. But graph is so much more expressive. I mean, I was, as you say, grokking it because I was doodling what one table meant and how that schema of that table touched another table and what this represented in the real world. Databases don't show you business life cycles. Databases don't explore policy or events.
Yeah.
Always. Sometimes they do, but not always.
Yeah. Yeah. And actually, you could argue that graph databases don't represent policies really either, right? They certainly don't represent behaviors. So, like you mentioned, an important term here in the description, and actually that is really interesting because you took a holistic approach to understanding a problem space. In other words, you were tasked with a job, and you were like, "Hey, or to use your term, to do my job, I need to know operationally end to end and top to bottom all the elements because I can't fulfill your need
Right.
unless I understand it, and or you're just going to get mad at me or I'm going to fail. Why would
I,
anybody do that?
I don't
But you,
understand how somebody can navigate something that they don't know in in the fog of war of I don't know what the hell that touches. That's not my job. Like that doesn't exist in my world. And I don't know how anybody could navigate that without looking deeper inside of the organization.
all right, so I'm gonna pick up on the term if you don't mind me taking a segue. Um, I'm going to pick up on a term that you used that I think is both super relevant, but also based on its implementation has different connotations, right? So schemas, right? Because we're talking about models and we're talking about schemas and exposing them, right? But we're also talking about context and we're talking about real time and models evolving. And part of the problem that you diagnosed correctly on relational databases is the schema is rigid and hierarchical, and often through at the application layer, the schemas are not even transparent, right? And then when you start manually integrating things together, that schema even becomes farther removed from you, right? You're as you go up the stack to the application, as
You're
you go
giving
up,
me flashbacks, man.
yeah, yeah, yeah. You're gonna have nightmares tonight. As you go up the application stack, that schema becomes more and more opaque to you. But actually, if you think of it, if you want the schema to be responsive to the consumer of that application, then we're doing it outside. We're doing it inside out, right? We really want to flip the script, right? We want to be driving things from the interaction
Right.
into the system.
Actor behavior driven rather than infrastructure driven. Absolutely.
Well, because if you do everything otherwise, it goes back to that what you call premature optimization, right? If it's all done by the great architect at design time and the Wizard of Oz designs everything in advance, oh, that's great. The Wizard of Oz is essentially a totalitarian dictator who has constructed a world that you merely live in. But the reality is that's what nobody wants anymore, right? What everyone wants is something much more flexible. And if I may, you just so many great tangents here as you mentioned the web and everything like that. Well, what's powerful about the web? Well, it's the internet was, if you look at the protocols of the web, TCP, IP, HTTP, et cetera, like that, there are very few generic protocols. They didn't over when they consciously intentional design. This is you got John Postal who does TCP/IP. You got Tim Berners-Lee who does the web, right? You got a host of people that contribute to the construction of the internet and the World Wide Web. But they all consciously made decisions not to prematurely optimize. It's actually called Postal's law, right? You essentially are underspecify, right? You want to be relax constraints so you allow for more opportunities. And if you build a rigid system, you're all constraints. If you build a flexible system, the constraints are applied against the event based on context, as opposed to you just being at the point of somebody else's rule. And but let me ground that a little bit better. So the enterprise, when Fielding describes the enterprise, he's essentially, we're talking essentially about a key value, right? Right. Key equals URI, value equals resource, right? That's Fielding's description of the World Wide Web. What is that defining? It's defining a schemaless data structure. That's really important, right? So something that was not lost on me when I was doing my own research here on enterprise web is like, okay, I really want, and you go back 2005, 2006, right? The REST versus SOA wars. the introduction of NoSQL, right? That's all happening around that same time, right? And so the notion of schemaless is really sort of critical to the idea of late binding schema,
I
schema on
appreciate that. I
right,
appreciate that. I
yeah,
appreciate that.
right,
I
schema on read as opposed to schema on model time, right? So now if we bring that to graph data structures, and this if I really like to bring this in because that's a great thing as we focus on that, and you're exactly the right person to fact check me on this for your audience. RDF and LPG lead to static schemas. Graph databases end up being rigid data structures. They're effectively anti-agile. As RDF and LPG are implemented, you're taking this triple that represents essentially a typed binary relationship. That's what a triple is, right? Subject, object, predicate, regardless of how you implement it. And then you're physically storing it in the DB as a triple, right? Well, of course, a single triple means almost nothing, right? It's like, you know, cat is a animal. Okay, that's a
so
single
like,
a single entity with a single property, right?
right.
A single parent-child relationship, whatever you want to do. Now, the reality is, okay, well, most things in life are more than binary, right? So as complex entities have more relationships, and when we think about the web or we think about the social graph, and now we're
complex,
talking what?
complex and dynamic.
Complex and dynamic, right? Because when we think about the graph, like the social graph, we can add friends. Sometimes we lose friends or connections over time, right? As we move into different jobs, we now have friends of different types from different aspects of our lives.
People
So
have children. People die. It shrinks. It shrinks. It grows. Uh,
exactly, right? So you have all these aspects of it, but that's not what RDF and LPG do, right? RDF and LPG are just two of the most well-known forms of graph.
but they're
Uh,
static representations of a particular state.
Well, because they're essentially a pre-computed graph. They are a physically representing a graph at a moment in time in a database. So, so they're known for faster traversal speeds. Why? Because what is a triple? It's a modeled join, right? You're making explicit all the joins. You're not making them dynamic. You're making them explicit. So you're building. What are you building when you build an RDF or LPG database? And it astounds me that most people who are working with these various vendors to do these things, they don't realize the wall they're going to hit. They're building these really deep hierarchies, right? They're building tree structures,
Mhm.
right? They're building recursive parent-child relationships that end up being trees, right? Almost like taxonomies on,
I'm, I'm sorry, Dave. I'm not gonna let you go at the hour. We're gonna stay here a little longer because you're touching on some really juicy ideas. Um, but please
Okay,
continue.
I will be your hostage then. Okay, but you're reducing the amount of post game we have. But I'm happy to do that one.
So, okay, let me just bring this to concrete terms, right? Because from my experience in the structured database space, um, there's the database. So SQL database, there's the schemas, tables, different schemas interact with different databases, but depending on how many applications, they're all sort of touching upon each other in some way if they're harmonized. Um, there's an ORM on top of the database, object relational mapping, some way to make the database interoperable with the programming language that you're using, the flavor that you're instantiating the application layer.
Yeah, that's
Uh,
where applications meet data structures. Yeah.
so then you have the uh, what was the word that you used? Imperative way of coding these hard structures that try to verbalize or express events and policies in a hard way. Then you have that transported through an API layer so that the server and the client are segmented for segmented concerns. So you can work on client facing applications and server facing applications separately. but you still have that interface, the API. A lot of people now are using REST API, communicating via JSON. You have the web app, which seems to be the way to go, because it's offloading the resources from the server to the client. Because now our phones are on par with computers as they were 5 years ago or whatever. Like they're super
Super
powerful.
supercomputers from 40 years ago, right? I mean,
Right, right, right. So that is a structure of well, what would you call that architecture? What is that?
I would call that a bolt-on architecture, right? Where you're or a sedimentary layer architecture, where you have different teams, database team, um, architecture team, application teams
Yeah.
that are laying down sediments that impact each other, and then they're all scratching their heads why the end result isn't flexible or agile,
Right.
right? And then when new technologies come out, they're like, oh, okay, you know what? We need metadata. Add on some metadata manager. We need APIs. We need some API management. Bolt that on. We need some notion of events. Well, so what do you end up getting there? It's back to the thing we talked about the very outset. A stack, right? You end up backing your way into this stack architecture, where the components of that stack are all tightly integrated to each other. Then the application layer is tightly coupled to the stack. And even if there are standards within them, the fact is they're implemented in a specific context for that specific application for a specific moment in time.
They're bound to that. They're bound to
They're
that.
bound to that, and they're not going to share nicely across other stacks. Now
So
think about the way the world is today, and we think about the cloud, and we think about horizontal architectures. So I told you my thesis was that silos were the enemy of agility, and the corollary to that was, well, if we look at our networks and infrastructure layer as horizontal and elastically scalable resources available to us, then the best thing would be that the application layer mirrors that we have horizontal applications that are elastically scalable, that dynamically consume the resources and network that they need as they need it, based on the application's intent, and that the application is consuming what it needs and driving its SLAs and other things like that, versus me exposing capability and you're just the benefactor of that capability, whether it fits your custom purpose or not. There's only, it's like hey, you can have any car you want, they all come in black, right? The Henry Ford thing, right? So and what we're in this, so graphs at one level create a form of database that addresses a problem on relationships that relational, ironically, relational databases don't solve that problem. COD, CODD, right? COD didn't solve that problem in his relational databases. So graphs actually give us a way to think about things in relationships, and relationships are a more natural way to think about the complex real world. And so that gives us some flexibility in representation. But the question is, how do I get representation? How do I get flexibility in my interaction, right? That's in my behavior, not just the model, but I want it to be responsive to the person. So if we go back to the graph structure as being graphs leading to triples, graphs being based on a data structure called a triple. Triples are binary pairs. When I want to do some, as things increase in complexity, I explode the number of binary pairs. So now all of a sudden I've created a relationship between scalability of my database and the complexity of the universe. As the complexity of the thing I'm modeling grows, my graph database grows in complexity too. What's the answer to that? I shard that database. Oh wait, sharding databases had some complexity too. It now adds overhead and complexity to processing. Now I normally have to be an expert in graph databases. I have to be an expert in distributing the graph database in a distributed system. Now I have new problems about updates and state management and things like that become problems in there. The more complexity I add, the deeper those tree structures become, right? So, cat is and the more RDFs I have, the more properties I add onto things, the more
there's a text to processing through.
tax, because I'm creating these deeper hierarchical structures, right? And so one thing that the graph database guys like to say is, yeah, Yeah, that might be true. I got a deep, I'm created a model. The model is representative. It is more flexible than a SQL relation. That's all true. And don't worry about the processing, because we have this thing called index-free adjacency, which essentially says, well, the traversal time between any two nodes is the same. Okay, fair enough. But the fact is, it's a compounding cost if I've got to go through 100 nodes or 1,000 nodes. It's a constant time, but it's a constant time times 1,000 or 100 or whatever I need to do. In computer science, we have this thing that we'd rather do with graphs, which is called flattening graphs, right? If I have a model that can flatten a graph, it means that, like, I know your 6th-degree relationship. I don't have to traverse relationship 1 to 2 to 3 to 4 to 5 to get to 6 or to number n or 100. I just go direct. I see this is the path. I flatten the path and I just go, I flatten the graph, and now I'm much more efficient in my processing but you cannot do that. That's fundamentally not possible in an RDF or LPG database because,
Sorry, go ahead. I please finish that constraint.
Yeah, because the strength and weakness of an RDF or LPG database is that triple, and their implementation of the triple is, remember, they call themselves graph databases. That's what those products are. They're not graph systems. They're not ontology-driven automation, which is the title of this talk, right? They are graph databases. They are an analog to a SQL or NoSQL database, but they're not a system. They're not the application layer. They're the database, and it's actually a pretty rigid form of structure. You mentioned object relational, but the word that generally goes with object relational, and for the attendees, object relational is just the bridge between two worlds. A database stores data in one way, and developers think in another way. Developers tend to think in objects because objects are a useful way to think about the world, right? And I want to connect and integrate objects, and I want then they come together into a higher level object, and that the higher level object becomes exposed as an application, and applications get chained in processes, and that's how developers think. But databases tend to think in either rows or triples, right? And so you have object relational. What object relationship mapping is the term that is used to describe that bridge. But in computer science, we call the problem from that, we call that object relational impedance, because those two things, it's like literally like I'm designing my applications this way and I'm storing them a completely different way.
Right.
And now at some point, I'm going to have a problem with optimizing my queries or my writes. My reads or my writes are going to become the problem. And so now you're assuming, it presumes, because that structure is rigid and hierarchical on the graph side, if I need to do lots of deep queries, I want to optimize that in advance. And then that's one problem, the deeper the hierarchy. The other problem is if I want to query across hierarchy, across trees, in other words, across different concepts, which have different tree branches. Now I'm going what's called east to west, not north to south down the parent-child tree. I'm going across the parent-child, across parents. That's super expensive in a graph database, LPG or RDF. And so what that means is you're left with this thing is that you have to predefine all your queries, predefine and pre-optimize your queries in advance, which really means that an LPG or RDF database will never support real-time complex ad hoc queries. That's what applications do. Applications want to be like, hey, I need to call what I need to call. I need to relate these things. I need to relate them right now. I need to understand them in my moment, in my real time. I need to understand these. I don't want, I'm sorry, you wanted me to write that query a week ago? I'm asking this question now. My application requires this answer, and so it means it requires a different kind of structure. There's a knock-on effect of that. I'm just logically proceeding through really objective issues, and and maybe in the Q&A somebody will jump on the call, or maybe 5 or 6, 10 people are going to jump down my throat and tell me all these things are not true. But I'm pretty sure I'm grounded in fact. There's another point.
I want to peel back just for a little bit. The pure idea that we are born in this world with a limited set of knowledge and experience. And as we go through our life, we engage in activities that give us new information, evidence, with our senses. We consume and integrate new information into our brain or our central processing unit. We have the scientific method of stating that we have a hypothesis and we have to make assertions. We have to test that hypothesis to continuously eliminate wrongful assumptions. It's not to prove of something, it's to reduce the errors around the thought. That is the scientific method. Um, so how do
based
we?
on, based on feedback, right?
Pardon?
Based on feedback, like
Yes, exactly.
the real
On,
world,
on reality.
the real world challenges your model, right?
So you invoke that those ideas, that thinking from your statement. We shouldn't tie the model to the data. We should tie it to how it's being used, right? Something along the lines.
We shouldn't tie the model to an implementation, a rigid implementation. We should let the model get interpreted, as opposed to compiled, right? In other words, if I have a pre-computed graph or predefined queries that are pre-optimized, everything's done in advance, right? That the road is paved for me already. I need to go down the paved road. The problem is in life, as you were describing, well, sometimes I have to go off road. I mean, but there's analogies that I think are completely applicable. If I'm a detective at a crime scene, I don't start by closing my mind based on the existing models I have to what's happened in the past, right? I start with the evidence, right?
Mhm.
And I go where the evidence takes me, right? And my conclusions might evolve as my
New information comes in.
as new information comes in, and gaps in my puzzle are filled. If I'm a doctor in an operating room, there might be an obvious reason you came in. You've got a a gunshot wound to the chest. I could see that. That's obvious. What I didn't know is that you have these allergies. That when you fell after the gunshot, you hit your head, so you actually are deeply concussed. Right? So now I have to worry about counterindications. I might, if I just rushed to treatment based on a singular fixed idea, I might give you a drug or a solution that doesn't treat you holistically for the set of problems that you have. Right? And actually, the paper that my chief system architect Bill wrote was on dynamic interoperability in a healthcare setting. How do I want to build processes that unfold with the knowledge we gain of the patient in the operating theater?
Right.
All right. I want systems to be, this ends up being going back to the 60s and the ideas of expert systems, and it actually goes back further to cybernetics and other ideas like that, where people in the 40s and 50s were actually already thinking this way. I mean, this is the important thing. People, before there was infrastructure, we're living on old ideas right now. If you live your life today, you think like you're the modern, right? You're the current person, right? You're the modern. Everybody who lives today has the bias of they're the modern, right? But the reality is, people in the 30s, 40s, and 50s, computer scientists and mathematicians, were thinking about in these because they didn't have infrastructure. They did mind experiments. They thought about how would I do something computationally in math so that I could actually have a fully dynamical system. So there's things called like viable system method, VSM, Stafford Beers. That's from the School of Cybernetics. That's like from the 40s and 50s. Then we were talking about, there's this guy, Ashby, and he's got Ashby's law, which is the law of requisite variety, which says that every system that you build, if you're has to be as complex as this, what you build has to be as complex as the domain you're modeling, or it won't mirror it. Right? You can't build a system and expect it to support the complexity of your real world if you build it and it's very shallow, right? So, so people were having those ideas. So enterprise web was based on how can we build practical implementations of fully dynamical systems. And so I just to close the thought on graph, because there's one other problem with graph I just want to point out is because of those deep hierarchies, it caused the query processing problem, query processing down north to south, query processing east to west, query processing across shards. So you end up, complexity becomes a growing tax in a graph database that you cannot escape. It's a tax you will pay, right? And it's also a rigidity that you cannot escape. A knock-on effect of that is it creates an update problem. Well, if my system is statically implemented by a series of RDFs that are sharded across multiple databases, how do I write an update across all the shards? Well, you end up doing something called a cascading update. Well, that's a really expensive process too, to get consensus across all my sharded databases. So not only do I have a query problem with graph databases, I actually have a write problem, an update problem. And these are studied problems, right? I mean, not everybody's going to take what I say. I assume some people are going to take this with a grain of salt, or people will come at what I'm saying with their own backgrounds and experiences, and some people will challenge it. That's all good. I completely enjoy an open, candid, and objective conversation. But those are fundamental problems. So just to get to the gist, when we built it, I studied that deeply, right? And then I said, okay, I can't build my graph that way. I want to build something more schemaless, something more like the web. I want it to be more like a key value, but it had to be it had to be more than key value. So I ended up building something that's more, to people who understand databases, much more like an entity attribute value. It supports EAV, is that area of computer science and database science. And I wanted to do that in entity attribute value gives me something that supports something that you would call a sparse matrix. It supports a much more schemaless structure that it can late bind based on policies, right? And I could, in our system, we were building something much more than just a graph of concepts or a graph of data. Enterprise web is based on ontologies, concepts, types, and policies in the graph. So the graph just doesn't help me reason over data. It's not just about analytics. It's not just about recommendation. It's pipelining the transformations, because I actually have functions in my graph, which means I can actually do it in enterprise web every time you call it. So this is literally the kernel here. Our runtime, enterprise web, is a fully dynamic system. If 10,000 people call enterprise web, even if they all call for the same object, the system is going to dynamically distribute agents, right? Agents that live ephemerally for like milliseconds, and it's going to create an explosion of agents that are essentially just isolated processes running inside enterprise web that horizontally scales out. That's going to respond to every single request, which is a query or command against enterprise web. It's going to see that, Joaquin Melara is calling me from New Jersey. He's calling me from this kind of device at this time of day. I got all this in-band metadata. In the request, Joaquin requested a specific object. The system is going to immediately filter that for who you are, your security, your permissions, right? It's going to filter the graph to immediately say, okay, well, sure, you're asking for this object, but 10 other people might ask for the same object, and they might get different views into that object based on their permissions. That's step one. Then I'm going to take that in-band metadata, and I'm going to project it against the graph of what Joaquin can access. And I'm going to start contextualizing Joaquin's experience. I'm sorry to talk about you in the third person, but I'm going to start contextualizing your experience by projecting you against the bigger graph. And in that graph, there's functions too, so I could do inline transformations. So I'm essentially enterprise web, for every single caller at scale, is dynamically constructing a data flow functional process that is taking data into functions, transformation, calling other data and other functions, and it's building out a pipeline to essentially contextualize a response to you. And we do that at millisecond speed, where literally we'll do thousands of interactions, thousands of operations against the graph for every caller at scale for a distributed system, and do that safely with IT governance, reliable messaging, transaction guarantees, state management. Enterprise web does all the dynamic indexing, dynamic tagging. Nobody has to become a database expert. Nobody has to understand how a database has to work. The database is abstracted away from the developer and the user. The system handles all state management and persistence, provides a complete trace of all activity. So what I was trying to do is say, I wanted to call out and make a distinction that might not always be clear, that not all graphs are created equal, right? The graph is a bigger domain than just semantic web. It's a bigger, and of course, semantic web people might have a bone to pick with me, and labeled property graph people might have a bone to pick with me. But the world is much bigger. Graphs are an idea again that go back, hundreds of years to the bridges of Königsberg problem, right? Euler, and it goes back further. But so it's a mathematics problem. It's not just a database problem. It's not just about data. It's about how we look at the world. It's how we describe objects. It's how we make models. It's how we contextualize things. And I think that there's a growing awareness in the world that things like LLMs and AI really need that context. They need that domain knowledge to ground their own behaviors, as well as the behaviors of the connected systems. So, excuse the monologue.
No, no, it was good. It was good. I had one last question, and we can conclude the call. I will release.
My favorite color is blue.
No, that's fine. You can keep that one. I wanted to ask, what is a gold nugget that you can share with someone who's coming into the space like brand spanking new, and they want to understand how to traverse the problem space to develop an architecture that has evolution baked into it?
So I think being new is not necessarily a problem, or being new to a problem space is not a problem. It actually could be helpful. I think part of the problem we have today is many people are stuck in their old way of thinking, their old paradigms, and while thinking in graphs, as particularly in dynamic graphs and relationships and context, is actually honestly much more intuitive to the business. I mean, going back to if I go to a business person and I very simply summarize for them, hey, your graph, your enterprise is a graph of people, information, and capabilities, they'll go, yes. And if I tell them they should see it that way, they go, yes. And if I say you should be able to look down on your enterprise as a graph, they're going to go, yeah, why don't I have that, right? And if I tell them that their processes are just sets of tasks that are connected by graph relationships as well, that are also contextualized based on events and policies, they'll say yes. So in other words, what you and I have been discussing for the last 90 minutes now is actually very intuitive. So being new is actually coming to it new or fresh. A fresh set of eyes can be actually really useful. I'd actually even suggest that people who've been working in the space for a long time also start by actually opening themselves not up to think horizontally, to be a lateral thinker. If you want to solve to think actually like what you described, when you were given a task, you didn't just look at the narrow task and put your blinders on. You looked at all the dependencies, right? Because that's what graphs model, right? Like graphs actually model dependencies, right? And relationships. So you didn't put on your blinders first and say, I'll just assume that the person who gave me this instruction only wanted me to do this very small thing, and that's all I'll do. I'll ignore everything about the rest of the universe, and I'll just deliver that. And if you asked your child to do a task, let's say a teenager's child, to do something, and they implemented it super narrowly to your word, right? You'd be like, seriously, you didn't bring any context to our conversation. You did just, if I say, can you, pick up your floor, right? Pick up your room, right? I really meant clean your room, darn it, right? And I wanted you to expand on the context. I wanted you to do all that that meant taking out your garbage, clearing off the counter space, folding your clothes, making your bed. I was speaking in a human form of expression that was super concise. You knew what I was saying. It had a context, and don't be a wise guy with me, right? Please take the action when I speak to you deliberatively. Please act on it deliberatively. So I think the word of advice, as I would say, is, technologies come and go and they evolve very rapidly. Don't build for today, which is going to be yesterday, tomorrow, right? Build for futures, right? Build systems that last, build systems that evolve. Think through your problem space and what does that really mean. Do your research. The technologies that exist today, we're doing it. We're doing it from the world's biggest companies, and we're getting and generative AI has been a blessing for us, because a lot of ideas that were very obscure, including graph. I mean, graph is still a fairly small niche industry, but it's about to explode, right? Next year you can check on my prediction whether 2024 was the year of the graph or not. But I think that it's not just going to be the year of the graph, it's going to be the year that the domain was understood to be the biggest asset of the enterprise. And so people need to think big. They need to think, stop thinking about just narrow use cases, just stop thinking tactically, start thinking strategically. That will make you more of an asset.
Right.
Right. Because honestly, a lot of people are being laid off in droves already by the tens of thousands if they think narrow. So the only people that are going to remain well employed are going to be people who can think laterally, people who think creatively, right? People who solve big problems. Those are the people who will have futures. People who think analytically, right? Those people will have futures, and people who are task oriented will get replaced by task oriented software. Sorry. I don't want to close on a down note. I think the up note is that people who are curious, passionate about this space, we're in our moment right now, right? This is our time, right? We've been waiting in the wings with graph and computer science and abstractions for a long time. It's been sort of the winter of the graph for the last decade, and now we're emerging from the graph winter. And graph is going to become a practical tool, so practical that graph will just become ubiquitous in the way we think about the world. That will be a good thing for the future of the world.
I think one of the biggest takeaways for me from this conversation was the idea that we shouldn't tie ourselves to implementation. We should do as it is idealistic in this practice of computer science, mathematics, science, technology. Stand on the shoulder of giants. Don't stand in the toes of gnomes, because that's what some people tend to do with limitations of limitations of limitations. Thinking in tools, you're just boxing yourself in for a very rigid solution, very rigid career path. Thank you.
And that worked for a past time. Remember when we were young, the world was much slower. It was highly centralized. It was pretty much static, right? I mean, the 1970s and 80s, right? I'm older than you, Joaquin. But into the 90s, things got a little bit more dynamic, right? But remember, there was a time even before FedEx. You have to remember, things moved slow. When change was slow, then having hard-coded systems and being infrastructure bound wasn't realized as a problem. When things move fast and things are more dynamic and evolving much more rapidly and much more distributed, now it's perceived as a problem. And so that's why we are people of our moment.
Thanks, Dave.
Fantastic. Joaquin, this was a pure pleasure.